Okay, so now router 1 is performing load balancing. Now my requirement is I don't want to receive 40 prefixes via router number 2. Via router number 2. So can I achieve my task with the help of a standard ACL? See, we cannot apply the distribute list on router number 2. See, the topology table or routing table of R3. So IP route EIGRP. It have installed these all prefixes via router number 4 directly, right? 34.1.1.4. So IP EIGRP topology. In topology table, also we router 3 have only one path, but there is one alternate path as well via router number 2. If let's say f1/0 of this interface will goes down, f1/0 say shut down, and so IP route EIGRP. Now it have learned these all prefixes via which router? Via router number 2. So if you will apply distribute list on router number 2, router 2 will not advertise prefixes to router 3 also. Yes or no? So we cannot apply a standard access control list on router number 2. So if you will think that I will create a standard ACL on router number 2 and I will apply that standard ACL and distribute list, then it will work fine. No, it will not work fine. Actually, I want to filter 40 prefixes on router number 1 via router 2. I don't want to receive 40 prefixes via router number 2. This is my requirement. And other routers should not be in effect. Can I achieve it with the help of a standard ACL on router number 1? No guys, we cannot achieve it because as you know in a standard ACL, see, when you will use a standard access list to for the identification of classes, access list 10 and then permit. After that or deny. We can define what? The network. We can define the network directly 40.1.1. Let's say 40.1.0.0.0.0.255.255. So here I have matched all network, right? And then you can see we don't have any option to define source. We cannot define here source. Only we can define what remote network, destination network here. So we cannot achieve my task with the help of extended ACL. So here I need to create extended ACL. Access list 101 we can use. Then deny. Which traffic? 40.1.0.0 wildcard mask 0.255.255. And after that, if you will put question mark, here we need to say IP as well. IP deny this one. Let me check guys what is the wrong here. Here deny, then which protocol? IP, let's say. After that source address, then source address 40.1.1.0 40.1.0.0 and 0.0.255.255. After that destination address. So what I can tell to this access control list, that whenever traffic will come with source what? Whenever router 2 will advertise these prefixes to router number 1, what will be the source? Source will be the IP address of exit interface, that is 10.1.1.2. Yes or no? So I am saying source should be this one and destination wildcard is this one and destination 40.1.1.0 40.1.0.0 0.0.255.255. Can anyone tell me, will this work? Will this extended ACL work, guys? In the traffic, source will be 10.1.1.2 2 and destination will be this one. It will filter. Nirav?
It should filter actually. It should deny
It
the
should
first
deny.
match.
Access list 101 permit IP
Any.
any router EIGRP AS number 10 distribute list number 101 direction in. I have applied it in direction. Soon EIGRP neighborship will resynchronize. So IP route EIGRP. Now you can see all prefixes. Router 1 is getting all prefixes via router number 1 only. Means it have filter via router number 2. So when we need to match source address also, that time I will use extended access control list to filter. Done. Any other requirement or any task anyone want to perform in this topology? Like your requirement can be anything. Just you need to create the scenario that I want to filter these prefixes via this router like that. Anyone have scenario?
Yes, sir. First three prefixes by R2 and the rest two prefixes by R3.
Okay, so you want to apply filtering for upper three prefixes via router number 2.
Yes, sir.
Okay, so can I achieve it? Can I achieve this
Yes,
task?
sir,
Yes.
Router EIGRP is number 10 and no distribute list 10 direction in. Not that 101. Right. I have removed the configuration. Now do again, it will perform load balancing. Now again it is performing load balancing. Now what I am going to do, access list 101 deny IP and then source will be 10.1.1.2 wildcard mask this one. Destination, what will be the summary address of upper 3 network?
Three 3.255
10.1. upper 3 0 na 0.0 255 255 252.0. This will be the address, na brother?
Sir, wildcard mask will come.
Oh, sorry.
Wildcard mask 3.255
0.0.3.255. Done. Access list 101 permit IP NE NA. Router EIGRP as number 10 distribute list 10 direction in. Now what will happen? What will happen, guys? It will not receive upper 3 prefix from router number 2. So IP route EIGRP. But you can see here it is performing load balancing for all prefixes. Why? Where is wrong? Why filtering is not working? So IP protocol. In so IP protocol, we are able to see. Okay, my access control list is not 10. My access control list is 101. So access list It is 10. I have created access list 10 over here. No. Let me remove it. No access list 10. Do so access list. We have one access control list 101. Source is this one, and okay. Now fine. Router EIGRP 10. No distribute list 10 direction in, and distribute list 101 direction in. So IP route EIGRP. It is receiving the upper 3 prefixes via which router? Via router number 3, and it is performing load balancing for the lower 2 prefix. But you want to receive lower 2 prefix via router number 2?
Yes, sir.
You don't want load balancing, so you will create one more access control list. Access list 102 deny, and this time source will be 10.1.
1.2.
1.2 or 3. It
Sorry,
should not
3, sir.
receive from router 3, na? So
Yes,
it
sir,
will be
yes.
3, 0.0.0. And summary address of lower 2 network 40.1.4.0. Wildcard mask
4.0. 0.0.3.0. 3.255.
3.255. Router EIGRP S number 10. Distribute list
Distribute.
number 102 direction in, and we need to create one more access control list with same number with permit statement, permit IP any. Clear IP EIGRP neighbor. So IP route EIGRP. It has started performing load balancing for upper 3 prefix. So actually only one distribute list is working. So IP protocol. Which one is working? 102.
Yes.
So we can define only one distribute list. We can create only one distribute list, in one direction. Okay. So guys, okay, with the help of one distribute list, can I achieve this task? Can I achieve this task with the help of one distribute list? Tell me. Just think and tell me. Hello. Think, is there
I
any
think no, sir.
possibility? Can we create access IP access list? P access list 101 extended up to that number 101. Then deny 40.1.1.0. deny IP 40.1.1.0 0.0.255.
I think
Okay,
that is the suit.
we are creating extended ACL. Now we cannot achieve, brother, that task here. Okay, we cannot achieve with the help of, you want to use here, you can use summarization, brother, for your requirement, as we discussed in yesterday class. With the help of summarization you can achieve this. You can use this path for upper 3 prefixes and this path for lower 2 prefixes with the help of summarization. Yes or no, brother? Yes or no, guys? Nirav, can you achieve this task with the help of summarization or not?
Yes, sir. Yes, sir. Through
Simply with the help
summarization,
of
we can
summarization I can achieve. Here we cannot
because
achieve
it
it.
will. Yes, sir. Because it will. After summarization, it will impact the prefix length. That's why.
Yes. Okay. So till now we have discussed route filtering with the help of extended ACL and extended ACL. When we need to define source as well as destination, we will use extended ACL, or when we need to, use the protocol, then we will use extended ACL. Otherwise I can use extended ACL as well. We don't have problem. Now let's say my network is not like this. My network on router number 4 is 40.1.1.0/24, 40.1.2.0/25. Here it is 24, it is 25, it is 26, it is 27, it is 28, 27, 28, like this. Router 4 have again 5 network only, but each network have different length, prefix length. And if you want to filter the prefixes with the help of prefix length, then you have other tool called prefix list. Then you have other tool called prefix list for filtering the traffic. Let's say now I want to filter the traffic whose length is starting from /24 to /25. Right? Doesn't matter which network is there. Getting my point? With the help of prefix length, let's say I want to filter all the prefixes whose length is starting from /26 to 28. That means these 3 prefixes I want to filter. So we have a tool called IP prefix list. Guys, in access control list, like on router number 1, still we have some distribute list and router EIGRP 10, no distribute list, 102 direction in, and do so IP protocol. We don't have any filtering now. Yes, and do so access list. So we have access control list. Say no access list 101 and no access list 102, and do so access list again. We don't have any access control list as well. Router EIGRP 10. I have removed the redistribution here. It should receive all 40 prefix, so IP route EIGRP. It is performing load balancing. Now on loopback interface I am going to change the IP prefix length. Actually I'm going to change the prefix length. And in access control list, whenever we are creating access list, let's say access list 10 permit 10.1.1.0. let's say I have just created one entry over here, and do so access list in access list you are able to see this number is sequence number of access control list. This is sequence number. So whenever we are creating access control list, it is starting with sequence number what 10, and there is the increment of 10. So if I will create one, if I will give one more entry in access list 10 permit, and let's say 20.1.1.0. So in access list 10 I have defined two entry. So sequence number will be 10 and 20. Here you are able to see sequence number 10 and then sequence number 20. So whenever router will receive any traffic, first of all it will check lower sequence number entry. Getting my point? In access control list we have two statements. First statement have sequence number 10, second statement have sequence number 20. That means whenever we are creating access control list, first sequence number will be 10 and increment will be of 10. In the same way, whenever we will create a prefix list 10, whenever we will create prefix list, IP prefix list, sequence number of prefix list will start from number 5. Okay, so if you want to define the prefix list number over here, you can define. Otherwise, here it is asking for the sequence number or the name of your prefix list. Let's say name is CCNA. After that, you want to deny or permit. So let's say deny. Then it is asking what network prefix. So let's say prefix is 40.1.0.0. After that, prefix length is /16, and then it is asking what greater than and equal to. Greater than and equal to means minimum prefix length to be match. Minimum prefix length to be match. So greater than equal to is equal to is 25. That means it will match the prefix which have minimum prefix length 25, and less than and equal to means maximum prefix length to be matched. So less than and equal to means let's say 27. So it will match how many prefixes? All the prefixes whose length will start from 25 and whose length will end on /27. The maximum prefix length is 27 and the minimum prefix length is 25. This is how prefix list will work. Getting my point? Like here I have configured this prefix list and do so IP prefix list. So you can see sequence number is what 5 over here, and I have defined one statement, that is deny 40.1.0.0/16 greater than or equal to 25 less than or equal to 27. Now I am going to remove this entry. Just I was making you understand the sequence number. Sequence number of prefix list is different from access control list. Getting my point? Now on router number 4, I am going to change the prefix length of these prefixes. Okay? Or it will be better if I will configure it in another topology, but leave it's fine. Here on router number 4, you can see how I am going to use prefix length. So let me take you to R4 interface range loopback 1 2 loopback 5. Say no IP address. Done. After that, interface loopback 1 IP address 40.1.1.1 255.255.255.0. Interface loopback 2 IP address 40.1.1.1.1 2.1 subnet mask 255.255.255 dot. What will be the subnet mask here for /25?
128.
128. Interface loopback 3 IP address 40.1.3.1 255.255.255. Yes, what will be the subnet mask for /26? 192.
194.
Interface loopback 4 IP address is 40.1.4.1. subnet mask will be what over here for /27?
224.
224. Interface loopback 5 IP address is 40.1.5.1. Subnet mask will be what? 255.255.255 dot
240.
240.
248.
240.
240, sir.
240. Okay, done. So IP EIGRP topology. It have installed this network, this network, this and to this. Okay, done. Now let me check the routing table of router 1. So IP route EIGRP. So it is receiving 40 prefixes from two side, and prefix length also you are able to see the prefix length. Now this time I want to filter prefixes with the help of prefix length. So guys, on router number 1, let's say I want to filter the prefixes whose length is starting from 25 and ending on 28. So command will be very simple, IP prefix list. After that, name of your prefix list is, let's say, CCNA. Then deny 40.1 deny 40.1.0.0/16 and greater than or equal to 25 and less than or equal to 28. I want to filter these prefixes. Okay,
27,
after
sir.
27. Why 27? Let me add one more network over here if you want.
Yes, sir.
40.1.5.6.0/24. Done. So on router number 4, I am going to add one more loopback. Interface loopback 6 and IP address is 40.1.6.1. 255.255.255. This is not /24, this is /29. So what will be the subnet mask?
252.
Two-
So 248.
248. Very good. 248. Right. And I am filtering the prefixes whose length is starting from 25 and ending on 21. Minimum length should be 28, maximum length should be 25. These prefixes will be filtered over here. IP prefix list, need to create one more entry with name, prefix list name, permit, and any means 0.0.0/0 and less than equal to 32. That's it. Okay, if you want to verify, do so IP prefix list. You can verify. We have created one prefix list whose name is CCNA. We have two entry in this prefix list. First entry is deny 40.1.0.0/16 greater than or equal to 25, less than or equal to 28. And we have one more entry with sequence number 10. So here you can see increment of sequence number is of 5. 10 and permit 0.0.0.0/0 less than 32, less than or equal to 32. Now I am going to apply this prefix list in EIGRP. So router EIGRP AS number distribute list. After that, if you will put question mark here, you can see I have one option of prefix. Filter prefixes in address update. Okay, so here I am going to use this command prefix. After that, it is asking name of your prefix list. So name of your prefix list is CCNA, and then in which direction you want to apply. So you want to apply it in direction. Done. Soon EIGRP neighborship will resynchronize, and again router is going to refresh their routing table and topology table. Done. And so IP route EIGRP. Now you can see here we have only one network, that is 40.1.1.0, and it is performing load balancing. I think I have not advertised last network in EIGRP. So let me take you to R1, R4, and here I am going to advertise last network also. Router EIGRP, router EIGRP, yes, number 10, and network 40.1.60.0, done. Once I will advertise this network, so router will install this one also, you can see. But all the prefixes whose length is starting from 15 to 28, all prefixes are filtered, yes or no? Yes guys, is it clear? Is it clear guys? Rohit?
Yes, sir.
Yes Rohit. Nirav?
Yes, sir. Clear.
Mohan? Mohan, am I audible? We will discuss advanced, filtering as well. But first we are discussing the basic filtering. These are the basic filtering.
Sir,
Then I will make you
so
understand advanced filtering as well. Yes, Nirav.
basically, like we need to use a distribute list. Okay, so for using access list also, simply access list also we can filter. Second, you showed distribute list. In
No,
distribute
now you
list,
are filtering traffic in EIGRP, brother, not on router.
no. I'm
Through access
uh,
control list.
through access control list. We classified and we did the classification and then we applied it using the distribute list. Correct.
Yes.
And in IP prefix list also we need to use distribute list. Correct.
Yes, exactly. These are the tool. Either you can use
Okay.
extended ACL prefix list or route map. These are the four tool which will tell to distribute list that which traffic you need to filter. That's it.
Okay.
Hi, this is Michael. I have a question.
Yes. Go ahead.
So the when you are editing ACLs, access control list,
Mhm.
if you say no, does it edit? Does it like delete the command?
Sorry?
If you say no to an access control list, does it
Yes.
delete it?
So if I have created the access control list, now it's not required. So just I am removing that access control list by running command no access list 10.
Does it remove like the if it's like access control is 10? Does it remove like everything in that bracket of 10?
No, don't think about access control list now, brother. We will understand access control list later. Okay.
Okay, thank you.
Just we
Yeah.
are using access control list for classification of traffic. This is really not a class of access control list. Access control list is a
Yeah.
separate topic. We will discuss, we will apply, right? Through access control list also we can filter traffic, but on the router, not in the EIGRP, right?
Okay.
Now we are
Yeah, thank you.
discussing EIGRP.
That's clear. Thank you.
Okay, guys. So here, let's say in this topology, this time I want to filter the only 40.1.3.0 and 40.1.4.0. I want to filter only these two prefix. So what I will do? First of all, let me remove no IP prefix list name CCNA. So I have removed this prefix list. Do so IP prefix list. We don't have any prefix list. And router EIGRP ES number 10 and say no distribute list prefix CCNA direction in. Done. I have removed the configuration. Now I want to filter only two prefix 10.1.3.0 and 40.1.3.0 and 40.1.4.0. Only these two prefix. I want to filter only these two prefix now. So on router number 1, again I will create IP prefix list because we cannot achieve this with the help of standard ACL or extended ACL. So that's why here we have only one option, that is prefix list. So in EIGRP or any other routing protocol like in BGP or OSPF also, whenever you need to filter prefixes with the help of prefix length, you will use prefix list everywhere. So prefix list is different tool, guys. This is no tool of EIGRP. Just we are using this tool in EIGRP for the classification of traffic. That's it. So here I am going to create one more prefix list, IP prefix list. After that, name of prefix list is again CCNA. Then deny. After that, network 40.1.0.0/16. Again, my network will be same here, right? Like previous entry, but greater than and equal to 25 and less than and equal to 26. Done. And IP prefix list with name CCNA permit any means 0.0.0/0 and equal to 32, greater than and equal to 32. First of all, greater than is 25, less than is 26. Not here, I need to define this one. This is the default entry. Done.
Sir, here
Or here
with less than 32 we need.
less than 32. After that, router EIGRP AS number 10 and distribute list prefix CCNA direction in. We will wait for the resynchronization of EIGRP neighbor. And now you can see show IP route EIGRP. /25 and /26 has filtered. Yes or no?
Yes.
And now we have one more tool, that is route map for the filtering. Let's say, see, I don't want to apply any filtering over here. So I am going to say router EIGRP AS number 10 and no to this command. Say no. Again, EIGRP neighborship will resynchronize. Now see the very interesting thing. So IP EIGRP. So IP route EIGRP. Now see, router 4 have learned this network with metric what? This value. So now this time I want to filter those prefixes which router have learned with this metric. This time I want to match what? Metric value. So whenever your requirement is like this, you want to match the metric that can be not achieved by access control list and not achieved by IP prefix list. We have concept of other tool, that is route map. In route map we can match the metric as well. Getting my point? Like I want to filter the traffic whose metric is this one. So let me copy the metric, right? And we can do one thing. For some network I am going to change the bandwidth. So let me take you to router 4 and here what I am going to do, interface range loopback 1 2 3. Here I am going to say bandwidth is 1000. Done. Now on router number 1, router have different metric or same metric? Not different metric. Yes or no? Few routes have this metric 2693 120 and some prefixes have this metric. Now I want to filter those prefixes which have this metric. So I am going to copy this metric and I will create one route map now. Route map. After that, name of route map is CCNA. After that, deny. And then if you want to define the sequence number, you can define it, otherwise you can leave. So it will take the default initial sequence number. Here I am going to say match what? Matrix value. Watch, match matrix, and let me paste the matrix, this matrix. Getting my point? I have matched this matrix in the route map. I have created one route map with name CCNA. In that route map, I have matched this matrix value. Done. After that, I am going to create one more route map with name same, with same name CCNA. And after that, here you can define the sequence number or you can leave it, but here I am going to say permit, and here I am not going to match anything. So if you will not match, so automatically will match all. So this is like permit any. I have created one same route map, right, with same name, and here I have defined the permit statement. I have not match anything, so it will match all traffic. Done. Now I am going to use this route map with EIGRP. Router EIGRP is number 10. Distribute list. And then if you will put question mark, here you are able to see we have one option of route map. Then name of your route map is CCNA, and then direction. So in which direction? In direction. Done. Soon EIGRP neighborship will resynchronize, and then I will show you the output. So IP route EIGRP. See, all the prefixes has filter who have which matrix, guys? This matrix. So route map, this matrix. All the prefixes has filter who was using this matrix, not this matrix. Which prefixes has filter? Yes, with different matrix. I think I have created dot map with permit statement. So yes, permit statement sequence number 10, and okay. So all other prefixes is filter who is not using this matrix, only this matrix is permit over here. So that's why now router 1 don't have route 420 network and 34 network. So I can correct it as well. Go to say no route map CCNA, and route map CCNA sequence number is, let's say 10, and oh my god, here we need to define it with a statement. No, route map, name of route map CCNA, and then permit. After that, sequence number is, let's say 10. Then here I am going to say match matrix, and this is the matrix. Do so IP route EIGRP. Okay, match matrix, this one, and we need to create one more route map CCNA. Sequence number is, let's say here I am saying permit, sequence number 11, and I am not going to match anything. So IP route EIGRP. So route map. So this is the matrix which I have filtered. So IP route EIGRP, and here we have all the prefixes.
Oh,
So IP
hello.
protocol
Guard room,
name
what?
CCNA, all okay. This here also
Security.
it's
Tell me.
working fine. So route map. Tomorrow we will start route map. Don't worry, from the initial. So Okay, we don't have much time for today. I will check it later. This is with
New
permit
connection.
statement. Why not? I am not able to
Okay, okay.
create with deny statement. No route map, CCNA. Route map, CCNA, deny, and sequence number is, let's say, 10. Match matrix, match matrix, match matrix, this one, and route map, CCNA, sequence number 11, permit. So IP route EIGRP. Soon it will desynchronize the EIGRP neighborship. Filtering is not working, right? Don't worry, tomorrow I will start route map. We have some basic concept of route map, then we will move to advanced redistribution and advanced filtering. Okay, maybe if we will not discuss advanced filtering in EIGRP over here, because while redistribution and after redistribution we have lots of command and concept. So there we will discuss advanced route filtering. And in upcoming days when you will learn other routing protocols like BGP, so we have much concept of route map and prefix list of these tools inside the routing protocol. So make sure you will practice this thing, guys, by yourself. I have already shared 3 lab with you guys, so please perform those lab by yourself. Like, first try to perform all tasks of RIP version 1 and 2, then try to perform all tasks of EIGRP in topology 1, then topology 2. I have sent 2 topology for EIGRP. So try to perform all the tasks. Like, sometimes it is easy, I know, sometimes it is easy, like configure the hello timer and hold on timer, but you need to at least configure once in your life, right? In EIGRP, how to configure hello time. Okay, and I make sure you have no change the hello timer, but the command, I know, so please configure everything, all the tasks. Okay, Nirav, you also.
Yes, sir.
So that's all for today, guys. Now we will continue from